Okay, and also 12.1. I'm returning to you 2 pieces of homework. Okay? Yes. You didn't get back your 12.1. Did you submit? Does anyone have the answers 12.1 accidentally attached to your work? Oh, okay. Here you go. Okay, you should have received your 8.1 and also 12.1. Okay? For 8.1, right? I believe the more difficult questions I would have addressed it in class already. Okay, let me try to recall whether I missed, if there was any problem. Yes, I marked. I don't recall any problem. So anyone want to raise any issues regarding 8.1? No? Okay. Then I'll not talk about 8.1. For 12.1, right? Okay, 12.1 for question 4D. There are a number of you for the answer, right? Okay. So 12.1 question 4D. The answer is actually 3/10 u to the power of 2/5. There are a number of you who gave me 0.3/u to the power of 2/5. Do take note that this is unacceptable because in a fraction, okay, we don't put a decimal, alright, in the numerator or denominator, okay. So try to have things in the fraction itself as integers rather than as decimals, okay. So that's the reason why I marked wrong for 4D for a number of you, okay. Then I think that other than that, I don't notice any issues. Just that some of you were ahead of the lesson. You use product rule or quotient rule in solving some of the questions. Okay, it is useful to know how to actually simplify the expression first. Okay, instead of using product rule or quotient rule, because sometimes product rule or quotient rule could be rather complicated, and from there it will become a bit difficult to simplify. Okay. Anybody has any questions they'd like to raise for exercise 12.1? Don't have? Okay. If you have corrections that you need to do, please also do them. Then after that, put inside your AMATS file. Your AMATS file, I believe it is red color. Okay. So please file it out. Red flat file. Okay. Okay. Could you then now take out your exercise 12.4? Any problems for exercise 12.4 in question 2A, 2C, question 5 or 7? No? Okay. If not, could you please submit your homework to the front? Yes. You know, it doesn't quite affect anything, right? 2, 3, 4. All in. Thank you. Are you planning to do a lot of visiting for Chinese New Year? Oh, you all know? You all don't know? So your parents will decide and then you'll just follow them. Is that how that's the case? Okay. Cannot earn as much money. Okay, let's continue with our lesson. We have been talking about tangents and normals, okay, getting the equations for tangents and normals. Today we're going to be looking at increasing and decreasing functions. Okay, so let's erase this one first. What exactly is an increasing and what exactly is a decreasing function? Okay, so we can think of it in a pictorial manner. Okay, so an increasing function, okay, could actually be something looking like that. This is just a rough sketch. It doesn't have any meaning at all. So we have something like this. What we see from here is that when my x values increase, let's say from A to B, okay, we notice that the corresponding value on the y coordinate, let's call this FA, since y equals to fx and x is equals to A, okay, and FB over here. So when x increases, we notice that the y values, they also increase. So that is the reason why we call this an increasing function. Then naturally, when we think about a decreasing function, let's say this is a y equals to gx function. We notice that as our x increases, okay, the corresponding y values, alright, actually decrease. Okay, so progressively you see that there's a drop. Okay, that is what we call a decreasing function. Okay, we want to actually use a certain test, right? Or rather, we want to develop a certain test to decide that, okay, whether a particular function is. You want to sit in front? Even if you sit in front. Oh, okay, long. Yeah. Why your specs? Broke ah. Okay. Scotch tape it. I'm not sure. Sure. Okay, so increasing function and decreasing function is this way. Okay, we want to develop a test to decide that for any function that we have, how are we going to determine whether is it increasing or decreasing without having to look at all the values, without having to look at the graph itself. Okay, and that is where we use our differentiation to help us investigate that. Okay, and to do our differentiation, since we understand that differentiation, okay, when we do a dy over dx, that helps us to look out for the gradient of the tangents. So if you were to look at the graph itself, we notice that if I'm going to draw a tangent at every single point, okay, it will always, alright, in the increasing function, always be a positive value. Okay, because in the increasing function, okay, for any tangent that we end up drawing, it will always be sloping upwards. Okay, so long as you understand that increasing function is to be defined this way, tangents will surely be positive. Okay, so our dy over dx must always be more than 0. Okay, so similarly, if you apply the same concept for decreasing function, if I were to investigate all the tangents that are possible to be drawn on a decreasing function itself, we notice that the gradient of all these tangents will always be negative. So dy over dx will be less than 0. Okay? Right? There is a possibility that for a function itself, it is not all the time that it is increasing and not all the time that it is decreasing. So one such example is your quadratic curve. Let me draw this better. Okay, let's say our y equals x squared. We notice that now y equals to x squared, it is only increasing in this section. Okay, because the gradient is only positive, right, in this section, and then after that, in the other part, it is actually decreasing. Okay. So it is possible that in one function itself, there are both increasing times and decreasing times. Okay, so in the y equals to x squared function, we notice that, okay, y equals to x squared is increasing when x is more than 0, and y equals to x squared is decreasing when x less than 0. Okay, so there is an interval given. I want us to just take a look at our textbook. Let me find the page first. Okay, our textbook page 30. Okay, in case you are a person who likes to read different kind of textbooks, or this our own textbook itself. Okay, I'll just write down one of the statement in that green box. Okay, notice that in that green box there is this statement that the derivative is more than 0 for all in this AB. Okay, y equals fx is increasing in AB. Okay, I want to clarify the use of this notation. Okay, what is AB itself? This is not your coordinate system. Okay, this is just another way of denoting that your x values is between A to B. However, in our own practice at this level, we do not use this notation. Okay, I never expose you to such notation. So please do not use it. Okay, we will keep this kind of notation as per our coordinate system. Okay, when you pursue further maths, okay, or higher levels of maths, then you may expose yourself to this. Okay, and that's where you understand further lah. Okay, I'm just saying this because in case you read the textbook and you're wondering what this actually means. Okay. Just for your knowledge, okay, so fun fact, if I want to say about A to B inclusive, right, okay, then we will write it in this manner. If I want to say A not inclusive, B inclusive, then I will write it in this manner. So round brackets and square brackets. Okay, so just for your knowledge. Right. I want us to first take a look at our exercise 13.2. So let's just start with some basic questions first. Okay, so looking at 1b, we are given y equals to x squared plus 2x for x more than 0. So in this question, they strictly specify that we're only looking at this interval. You're not looking at the other part of this quadratic expression. We want to find the expression for dy over dx and explain why is y an increasing function. So we first look at the derivative, and that will be 2x plus 2. Okay, and since the question specified that we're looking at x more than 0, then we manipulate the inequality. Okay, how we go about manipulating the inequality? We want to actually prove that dy over dx is going to be more than 0, so that we can justify that it is an increasing function. Because that was what we agreed upon, increasing function, dy over dx more than 0. So we want to show that 2x plus 2 is more than 0. We notice that 2x will have to be more than 0, since x is more than 0. Then 2x plus 2 will be more than 2, because 0 plus 2 is 2. And that will be more than 0. Okay, so since dy over dx is more than 0, then y is an increasing function for x more than 0. Okay. To just give question 2c a try. Try to prove that x to the power 6 minus 5x is a decreasing function. Okay, using a similar method that I did in 1b. Okay, give you maybe about 3 minutes. well done. Through. So I hope that I see that most of you are able to get the first derivative. Okay, so we have 6x to the power of 5 minus 5. Then to prove that it is a decreasing function, okay, so we say that since x is less than 0, okay, we can be very certain that x to the power of 5 will be less than 0 as well. Because x to the power of 5 will mean that it is x times x times x times x times x. Okay, and with 5x multiplying together, it will surely become negative because 2x's will be positive, 2x's will be positive, then with the third one, it will become negative, right? Because odd power. Okay, so 6x to the power of 5 will then surely be negative. Okay, and if it were to minus 5, it will be less than negative 5. So Joseph, I'd like you to put in this in your working. No, you didn't want. I thought I saw less than 0. Okay, no. Until I cannot see. Okay, very good. So 6x to the power of 5 minus 5 less than negative 5, then less than 0. Okay, so since your dy over dx less than 0, then fx is a decreasing function. Okay, for x less than 0. Okay, so these two questions are some simple ones, okay, to start off with the thinking and applying that concept. Okay, next we look at question 3. Okay, so in part I, we want to find the, Okay, earlier asked, must we write x power 5 less than 0? Okay, personally I find that it is a very clear kind of working. Okay, because if you look back at how we from here to go into here, the first thing we think about is the x power 5 rather than the whole thing. Because this is where the variable lies, so I will write this down. Yeah, I will definitely write it, so I will encourage you to write it. Whether you'll be penalized or not, okay, I wouldn't know, because I'm not marker for your O-levels. But I will encourage you to write out. There's no harm writing one. Right? I'm sure it just takes less than 10 seconds for you to write that. Oh. Okay, so part I, dy over dx, what would it be? Zhen Quan? 3x squared plus 3, good. Okay, in part 2, we want to hence show that y increases as x increases for all real values of x. Okay, so what this means is that regardless what x is, so long as x increases, we want to show that y is increasing. Okay, so an example of this whereby our function is always increasing would be something like your linear line. Okay, so let's say y equals to x plus x minus 5. Okay, so a linear line is an example where it is always increasing regardless of what value of x you see. Unlike how we saw y equals x squared, where it is only increasing at specific values of x. Okay, so this is what this question is saying. And let me just erase this. In order to prove that, okay, looking at our dy over dx equals to 3x squared plus 3. Okay, so this one, the question did not actually give you a head start in terms of the inequality, unlike our previous question. Okay, they are just asking you about for all real values of x. Okay, so how do we go about starting? We see that we have our x squared over here, that is the variable. Okay, and x squared will always be more than or equals to 0, okay, for all real values of x. Regardless of what is x, okay, x squared will always be more than or equals to 0. So, for all real values of x, x squared more than or equals to 0. Okay, I want to specify on the or equals to. Okay, don't miss out on that equals to. So because x squared more than or equals to 0, 3x squared will be more than or equals to 0 as well. Okay, and therefore 3x squared plus 3 is more than or equals to 3, which is more than 0, and that's how we bring in the more than 0. Okay? Then we say that so our y is an increasing function. Any questions? Yes, right now. Okay, so in our question 1, 2, and 3 that we actually done earlier, we looked at how we are going to go about proving that a function is increasing or decreasing. Okay, so now we're going to go in reverse to look at try 3, where given a function, okay, we want to determine the range of values of x for which y is actually increasing. Okay, so we are going in reverse from using this, okay, to find out the range of values of x. So we will have to find out our dy over dx first. And in this case, that is our 6x squared plus 6x minus 12. Okay. And in order for y to be increasing, our derivative must be more than 0. So we found this inequality. Okay? Now, this brings us to a problem, okay, where we need to recall how do we solve a quadratic inequality. So, how? We need to rewind back to 1 year ago. Factorize. Factorize what? How to factorize? Okay, you can take out the 6 first. Then, can I remove the 6? Why cannot? Can I remove the 6? Cannot? Can? Okay. The answer is we can remove the 6 because, okay, if you think about it, okay, it is not about dividing the 6 away. Okay, I want to just really drill into you, okay, that we are not talking about plus, minus, times, or dividing anything away, alright, when it comes to inequality. Okay, we are looking closely at the function itself. In order for this entire thing to be more than 0, okay, since this is equals to this thing, 6 is positive, this thing must also be positive. So that positive number times positive number will give you positive number. Okay, it's important to think that way because later on when I do more difficult questions, okay, I hope to be able to bring out the understanding and the importance to you. You cannot just divide 6 away. It's not about that dividing it away. Okay, so it is because positive times positive give you positive. Okay, that's why x squared plus x minus 2 will be positive. Okay, then from here we factorize. So could I erase this part? Okay, so we're going to factorize our quadratic expression. That will be x plus 2x minus 1 more than 0. Then we do this. Am I right? Yes? We do this. Joseph, time to revise. Okay? Is this right? No, okay? We don't do this for quadratic. Okay? Because like I mentioned to you, okay, we are not having equal sign over here. I cannot say that this is more than 0, this one is more than 0. Technically it does make sense because just like I said, well, positive times positive give me positive. But there's also another combination that can give me positive as well, which is negative times negative give me positive also one. Right? But we have never really went into that idea, okay, because it is quite a hassle to think about it in 2 cases. What we have always been doing is look at the graph, right? So negative 2 and 1. Okay, then more than 0, we look at this section and this section because that's where the 2 tails are above the x-axis. Okay, so there's more than 0. That's why x is less than negative 2 or x is more than 1. Okay, and that is the range of values of x for which y is increasing. Okay, so these are the answers. This entire statement itself is the answer. Do I go about writing, how will I write it? X. Does this make sense? It doesn't, okay? It might seem like I'm the correct one because x is lesser than negative 2 seems to be expressed here. X more than 1 is expressed here. But if you look clearly at these 2 numbers, negative 2 is not more than 1. Okay, so this inequality itself is not correct. Okay, so that's why we cannot combine the 2 inequalities. Okay, I know that me saying this seems like a very mundane stuff because seems like many of you know it already. But no, I just want to play it safe. Okay, in case someone is like Joseph, tell me just now that step is the same, is correct. Okay. Sorry. Please go and heal it. Okay. Now let's look at try 4. Okay, so try 4, we have y equals to 1 over x minus 1. We want to show that y is decreasing, okay, in each of these intervals. So it's similar to how we did in question 1 and in our exercise 13.2 questions earlier. Okay, so we will look for our dy over dx. So what will the dy over dx be equals to? What is the dy over dx? Talia, you seem done compared to others. What is the dy over dx? Do you use product rule? How do you use product rule? You make y to be equals to? do it like that, and then use product rule. Why you don't want to remove the 1 then? Can also, right? Also a bit redundant to use product rule, yeah? Okay, so bring down -1. Power become -2. Inside differentiate become 1. Okay? Sometimes as we get more powers and more skills, we tend to think very complicatedly. So always fall back to basics. So this is our dy over dx. Now we want to show that y is decreasing for this. Okay? So our objective at the end is to have dy over dx less than 0. So we will start with x less than 1. So with x less than 1, going to look at our dy over dx, we see that x minus 1 will be 1 minus 1, which is equals to 0. So x minus 1 is less than 0. Okay, but our x minus 1 square, okay, will be more than 0. Okay, so maybe let me just write this clearer. X minus 1 less than 0, x minus 1 square more than 0. Okay, I would like to ask at this juncture, why is it more than 0? Why not more than or equals to 0? Okay, very good. Because x minus 1 is not less than or equals to 0. You're in the process of filling your brain now. Okay, so x minus 1 down here is not possible to be equals to 0. That's why in this case, it will surely be more than 0 only. Understand? Okay, so with this being positive, we will see that our dy over dx, okay, which is a negative value over here, will be less than 0. Okay, so our dy over dx is less than 0. We can conclude that y is decreasing for x less than 1. Okay, could you do the same thing, right, for x more than 1 and prove that dy over dx is still less than 0? Okay, could you do that now? Give you about 2 minutes. get the answer? Alright, so I hope that you are able to show that do the same thing. So x minus 1, okay, will be more than 1 minus 1. So x is more than 0. Sorry, x minus 1 is more than 0. Even if it is more than 0, the square will still be more than 0. So dy over dx having a negative sign over there causes the overall function to be less than 0. And we draw the same conclusion. Okay, any questions? Now let's take a look at question 7 in your exercise 13.2. We are given something slightly more challenging where we have y equals to 3x plus 4 over square root 2x minus 1. We want to find the dy over dx and find the range of values of x for which it is increasing and for which it is decreasing. Okay, could I just give you about 2 minutes to differentiate this function? And we got to simplify it. Okay, reason because if you don't simplify, it is going to be very difficult for us to determine the increasing or decreasing part. Okay? Give it 2 minutes. Yeah, quotient rule, product rule. Simplify it. Are we done? I hope that you're able to simplify to arrive at this. Sorry? Or you can have it in radical form, no problem. You want to put it as this also okay. That's fine. Okay? Doesn't quite matter since the question did not specify a certain form required. Okay, is anyone having trouble simplifying to this stage? Okay, how to go from here to here? Okay, let me just explain now. Alright, what you can think about, okay, you're able to get this part, right? Okay, what you can think about is that we're trying to multiply the whole part here with 2x minus 1 and square root 2x minus 1 and the bottom by square root 2x minus 1. It's similar to our approach of doing rationalization, okay, where on top and bottom we do that, okay, but we don't actually write it in this manner because algebraically it's incorrect. What we could do is to multiply by one single fraction of square root 2x minus 1 over square root 2x minus 1. So this entire part multiplied by this, so this square root with this will give me 2x minus 1. And this part here times this will cancel out and we are left 3x plus 4. I want to emphasize that there should be brackets here because there's a minus sign. It will cause a change in operation. Okay? So if you are careless in that, then your simplification process will be affected. Okay? Understand? So previously when we did our chapter 12, it was okay if you left your answer this way because we were finding gradients, so we can just substitute inside and then after solve for this. But in this particular case, okay, now that we're looking at more challenging questions, more application type of question, okay, it is necessary to have it in simplified form, okay, because now we're going to look at how to get the range of values of x for which y is increasing, right? So in part I, any questions before I move on? Right? You may actually choose to do product rule, but even if you do product rule, you should be able to arrive at this. Okay? Anyone do product rule and unable to get this? What do you get? Okay, give it a try again. And then after that, let me know. Right? So in part I, we want it such that it is increasing. Okay? So for y to be increasing, our dy over dx, which is this here, will have to be positive. Okay? So this is where I want to caution you again. We cannot think of multiplying things over, dividing things over, because that's not right in the inequality. What this inequality is telling us that we want this entire, okay, expression over here to be more than 0. And this expression is made up of two parts, the numerator and the denominator. Or in other words, something divided by something. Okay? In order to have two things dividing each other to get a positive number, okay, there are two cases that we can look at. One is such that 3x minus 7 is more than 0, and 2x minus 1 to the power of 3 over 2 is more than 0. Because positive number and positive number, when they divide by each other, surely will be positive. Okay? Or numerator to be negative and denominator to be negative. Okay? But the problem here is that this is 2x minus 1 to the power of 3 over 2. If you wrote it in radical form, then maybe it will be clearer. So let me just adjust this one a bit. In a radical form, it will be expressed in this manner. But in order to square root a number, the number itself must be positive. Agree? So if the inside must be positive, the square root of it must be a positive number, right? Because the square root any positive number must be positive one. So this whole thing, can it ever be negative? Can never be. So that's why this case we no need to consider. Okay, so let's just write that down. Since 2x minus 1 to the power 3 over 2 is always more than 0 for all values of x, all real values. Okay, then we consider 3x minus 7 more than 0 and this thing more than 0. Okay? solving our 3x minus 7 more than 0, this inequality itself, this one is fairly manageable. We shift the negative 7 to the right. Okay, this is one of the linear inequality we can do that, yeah. Okay, linear inequality, we've got such skills. Okay, other than that, when it comes to non-linear ones, we cannot just multiply over. Okay. So we get x more than 7 over 3. Okay. The other one, we will then have to investigate it because this is non-linear. Okay. So for this to be more than 0, the inside 2x minus 1 must be more than 0. Because that was what we agreed. That the insides of the square root must be positive in order to achieve a square root. Now that we have become linear, we have two inequalities, x more than 7 over 3 and x more than half. Would this be our final answer? Do we end our answer here? What do we do? What do we do? We have to? Yes, we draw the number line, right? Okay, for us to visualize the placement of these numbers, so we got our half and 7 over 3 is our 2 and 1/3, so that's more than half. So x more than half will be this. X more than 7 over 3 is this. Look at the overlap. So therefore, x more than 7 over 3, you can write as 2 and 1/3. Okay. Or rather, writing in proper statement, y is increasing when x is more than 7 over 3. Any questions? Okay. Alright, I'll keep the decreasing part for the next lesson. Okay, then next lesson I will wrap this up. Then we can go into the deployment. The inside of the square root, when you square root a number inside cannot be, we cannot square root negative 4 for now lah.